Good morning again. Good morning, everybody. Namaskar. This is Suraj Singh speaking. Bharat India on this 27th, 17th June 17th, 2021. Last video disrupted, interrupted. So again, back to you, gentlemen, about quality. I was talking and continue on that without any interference. So I'm closing this certificate. No need of this, and I close this certificate as well. No need of this now. And quality issues talking, which I said I had talked about many issues in quality, and this now construction based quality. On that quality we'll discuss in coming time. I'm going back to my file, and that is requirement, quality requirement. We went to that one. We had I had discussed many, you can say, many methods with you people regarding buildings, regarding others. Many methods I talked from excavation to RCC, excavation activity to RCC, including formation activity, blinding, concrete protection, foundation, stub columns, and then backfill, then grade slab, columns above ground. Then you can say walls, various types of walls, lift walls, staircase we talked, suspended slabs we have to talk, then many footings we have to talk. Likewise, we are covering a lot of, not you can say immense, but some considerable experience based methods, based on experience, based on to acquire more and more. That's point means what is best, what is not best, just a kind of reorganization of activities. Organization of activities or reorganization, or we can say organization is a must. People may call it management, but I say organization because we, whatever we do, whatever work we do, small or big, it's a kind of organ on that project. It dissolves itself in that project. Whatever activity we do on sites, these dissolve themselves. These become permanent part of that project. Permanent part means we cannot later on say, we say we have delivered this project, we delivered this building, we delivered this structure, but actually we delivered a pool of activities, successful activities. When we say we deliver this project, hundreds and hundreds of activities go into place successfully. Those people who avail that product, that building, that structure, that person, those people do not know what was done because they use product and not activities. But activities are very important for producer, which is engineer or owner. Engineer is a technical producer, engineer is a technical designer, engineer is a technical controller. Technique means use of mind. Use of mind means engineering. So all these activities are not alone. These activities which are listed in or would be added later, all these activities have to go this way or that way, somewhere or other way. These have to go into works. In some way or other way, these have to go into works. If these do not go into works, into that good, you can say, that deliverable product, then there is no meaning of these activities. Combination of these activities, many of these, I'm not saying all, depending on project, many of these activities in group go to that project and assimilated in. After going into that project, these do not remain independent but becomes part of that project delivery. We have to keep in mind this is important point we have to see, just like we can say activity of setting out and excavation. Once building is delivered, structure is delivered, a common person cannot say what was set out, what was setting out. For that person, setting out has got no meaning, but for a surveyor it's a meaning, for an engineer it's a meaning. Engineer knows what was set out, excavation was done, but nobody knows what was done. This means once these activities become part of delivery, there is no existence of themselves and reality, but they represent someone. This excavation force doesn't exist now, but it was done. Same way, we can say whatever we do, it's not excavation. Then there are so many, other activities which were involved. Engineering activities, for example, coordination, designs, shop drawings, all those which we did, all those which we handled one whatever way, and we cleared those areas for this project. All those activities, all those methods which are made supports for this delivery, all those do exist somewhere in time, but now because these have been delivered, these are not visible to those who are not technical, but those who are technical, who understand this, they can chart out that this might be programmed. Now there is no meaning of repeating all that, because it's just I'm trying to show you for purpose of reference, means after all what is done from excavation to, that's what design is, that's what it is, and it's really very important. We cannot ignore it. I think why is talking about some suspended slab. I was talking about some suspended slab. I have to be very sure about this suspended slab. Then pedestal footings, and this I also think discussed where that one now for RCC works for DC generator and alternative foundations. And let us say slab, because this is very important part. This is a slab. It's very important part of that one. Though it is slab work, but I am going to tell you about pouring of this. Let's say what we discuss in this first, because that's also important. Uh, what we did in this while prepared, means we'll talk about pour, but let us see what we did when we handled its preparatory works. Just trying to connect to, because it's also important to understand, to refresh what was. Is that when we do some slab work, we have to do a lot work, and we talked of what conduct coordination, means coordination. It is root. It is, you can say, base base of engineering. Base of engineering, where there are so many disciplines or sub-disciplines are involved. Why we call it coordination? Do you know meaning of coordination? Everybody knows, I think. It doesn't mean inferior or superior. It doesn't mean junior or senior. It doesn't mean anything in vertical mobility or actually it's horizontal mobility. You can say that if there is graphics x, ox and y axis, we can say we say if you go value y is going upwards or downwards, higher is upward, lower is downwards, and we say x axis the same level value means there is no vertical application. That's what coordination is. It is same level, coordinate. Ordinate we have, not abscissa. I'm talking of ordinate. All stand at same level and their statures are same, no difference. That's called coordination. We should understand this. Nobody is small, nobody is big, but we measure ourselves. We measure ourselves to work. What work we do? That is the important point. We do some work all together. We have a common goal, and that is this work, this project. Everybody has some role to play. There's no one person, there are many persons involved in this because all disciplines are involved. So many people are involved. We have to consider that point importantly, not just for sake of because I'm saying no, it's not that. It means it may be building engineer, it may be electrical engineer, it may be mechanical engineer, or you can say some other form of engineering. They have a common objective depending on their involvement in that activity, relevant activity. Relevant means a specific activity for their discipline. Cost doesn't matter here. I'm not talking of cost because disciplines have different costs. There is importance of performance, importance of function. What function that would do? Electrical function is that successful supply and distribution of electricity, electric power in that area, in that coverage. Whatever coverage we give in that structure, it should perform well. Electric supply should be smooth and without any danger. That is role of electrical. If we do not provide electrical power to homes or to structures, then you can say something wrong. People won't accept this, and it's not possible because without electrical energy, life is dull. It's no more, So nobody wants that. There should be no service. Electrical service role, mechanical service role, HVAC service role, plumbing service role, security service role, many service roles, gas supply service role. There is no end to that. Whatever is involved in addition to civil, whatever is involved in addition to civil, all professionals are together there. Of course, not full time. Whenever they meet and talk of and do that. They stand on one floor, talk of that project, decide something or not done or leave it. But time required there for decision. So those people, when they work there on that project, they interlink with each other. That interlinking system, that interlinking procedure, what you can say, you may call it compatibility, particularly in electromechanical engineering, electromechanical, you can say, sub disciplines, lot of compatibility is required. Compatibility means what? This means we are talking of electrical engineering and machines. Both are together there. If there is no machine, electricity would not work. And if there's no electricity, machine would not work. It depends if it's electrical oriented machine or some other oriented machine. It depends on that. So we have to take this point into consideration. Definition of coordination. Definition of coordination. How to define coordination? Being an engineer's coordination meaning is very simple. That we have to do this work in collaboration, in joint efforts, with joint inter-exchange of information. Otherwise, our performance would not work. Our performance would not work. That is important point. This project shall work only successfully if we are together, if we understand each other, we have power of communication, we have openness in conference, we have openness in referring to each other problems and trying to find solutions. Try to find solutions. That's what coordination about. And if you don't do that, coordination, and say, no, I'll take care of my work and you take care of your work, there's no problem, we do it, but results won't be similar. Results won't be integrated. That situation is not acceptable. Compatibility mode, this machine must have supply of this electrical current with this frequency, what size of cable you need for that. You have to decide where to provide. Means both electrical and mechanical and others must talk together, must walk together, must bring in material to work together. Does that mean material is required today? I have brought machine to site, equipment to site, but electrical engineer was absent. Electrical engineer did not do anything, and machine has to wait for years or months on site to be installed. And in some cases, machine is on site, somewhere lying in the yard or in lake town, but there is no sign of any work. This is what I say. Coordination means you have to stand together on that project. You have to work out what your schedule says, what is mandate on a schedule. This schedule directs you when you have to bring that machine, and you have to keep site ready for this electrical fix or mechanical fix. Every service is involved with each other. And then civil. I have explained about electromechanical. What about civil? There everything stops. If civil stops, why should civil stop? That's also a point. Civil has got no right to stop because it is project, and civil is only that professional. Civil person is only that professional who comes at very beginning when there is no one. There was no one. We came to that point. There was no one. I was there. I was there. This means I was there. I was one. You don't say no one. Yes, I was there. I started contemplating on that. And then I invited all, come on and we discuss. So there, because it is civil project, in general you can say cost wise and size wise and time wise, civil has to give initiation project. Civil has to start site of project, temporary or permanent work, and then others have to emerge there. Other sections who are not civil, they would access there. Of course, not like civil regularity. They may come and go. Sometime they may come for a few hours, and that too after many months are over. Because activity they do is different aspect. It's different aspect. They may brought materials and keep somewhere in store because you cannot bring material every day. That is cost. It's not cost effective. So if you are leader, if you are leader in civil, you have to be leader for others too. It's not because of hierarchy, it's because of requirement. You have to interact with those people. Interaction, you have to encroach over them for purpose of not intimidation but posture. We have to be leader in ourselves. We have to be leaders in advices, in suggestions, not in just say, I am leader, don't talk to me. This cannot be called as such. Cannot be called as such. Therefore, what I try to say, meaning of coordination, what is coordination? Because it's not an ordinary word in engineering world. It's not an ordinary phrase in engineering world. It's something different. It's not coordination that I'm talking to you and you talk to me. Coordination of construction documents. What documents claim to say. Means coordination, you can say, on projects. It be design project or it be construction project. You can say can be Formula 1 technically. It's Formula 1. Technically, without which you cannot understand any procedure. Coordination should be taken as first principle in site works. It means you must go through all drawings, which means drawings. Which drawings? Those drawings which are already approved. You cannot touch other drawings. An unapproved drawing should be separately kept for record purposes. But work that we have to do should be done according to approved drawing. We call it IFC or AFC, the other abbreviations as well. Keep in mind that this point then I say drawings, which is you can say IFC, we call that. You can say issued for construction, we call them issued for construction, and AFC, that is approved for construction. And this is not structural drawings alone, all disciplines drawings like that, approved for construction. This is formal word, and if you don't have these drawings on major projects, you have no right to do work. Got my point? And these drawings are all coordinated drawings to some extent, but you have to coordinate to other services. Whatever schematic drawing we have to coordinate that with other disciplines and sub-disciplines. Ultimately, those who are going to be married, they have to think of that they should have coordinated approach everywhere. Married doesn't mean Husband, wife, marry with project. Try to understand. Marry with project. When you start some project, it's not simply a project. It's like you have to devote yourself into that project, and particularly civil, because civil project continues for years together, and you have to stay there to think of, to apply knowledge, to do it better. You take kid like, you know, you consider it your kid or your whatever your friend or whatever you say, you have to take care of that. But I say IFC drawing is one part. Then we have to study all drawings, all IFC drawings with civil drawings and structural drawings, architectural drawings. Means there are so many involved disciplines in construction, and if you cannot study them, you won't be able to find what you have to do. You won't be able to find what you have to do. That stamina of knowledge you are missing. When we decide something that we have to do this, or we chart out these drawings into study, and the study finds some errors in them, okay, this drawing speaks something and this drawing is speaking something else, then we have to find out solution by raising query to go that person designed it, or by sitting together and conferring on one of those items in meeting, and then material decision can be taken if it is empowered, or you have to refer it to those who are empowered. Same way we say, whatever we do, we have to do, we have to do in very big coordination work. There is exclusive work on sides in hold position that others are invited for that. Then we say, okay, we have got this. Now we go. I'll take some time. Be back. Hold on, please, because there's some work I have to do. I'll be back in 10 minutes. Hold on. So we come to checklist please. Okay, this checklist is quite clear what we said. It's quite clear here. I would say it's quite clear or understands this, that quality has gone. Now we're talking of this. So it's talking of coordination. It's a very important point here. Coordination. Without coordination, nothing is possible. In fact, nothing is possible without coordination. And coordination is actually basis of construction engineering. It's not only basis of construction engineering, it's basis of design engineering as well. And it's basis of electrical engineering, mechanical engineering, lifts engineering, gas engineering, because pipes have to pass everywhere, services have to work everywhere, and therefore inserts are to be placed in right position, and if inserts are placed in wrong position, they shall be clashed in future. Therefore, IFC drawing means you have to convert practical drawing. I mean to say, schematic drawings have to be converted to practical drawing, which must be used, which should give in clear dimension, clear direction, what to do according to trade practice. That's why I say coordination is important. And I'm not reading this statement, I'm just trying to explain to you what should be done, which should not be done. And if you don't do coordination, believe me, you cannot do work according to specific requirement, according to contract, according to professional acceptance. Then you can say these are all controls actually. I'm talking of controls, civil controls, which are main controls of building, access controls, grid controls, and all these lead to ultimately every control of services. Then you can say there are temporary works, there are other works which we discussed before. I'm not going to discuss with that one now. My purpose of this is only coordination, understanding. And coordination means work coordination, or you can say compatibility coordination, and also load distribution in meeting requirement to machines, load distribution of electrical energy. There are so many floors, so many areas, so many distribution boards, so many main distribution boards, sub-main distribution boards. These are all provided in buildings. Purpose is only that load that comes into from transformer to building, that load should be distributed proportionally to requirement. You cannot blindly distribute that load, and that is called load organization, load distribution. Just like we say in civil designs, our actions, our dead load, live load, direct load, this load, that load, is spread over many, or you can say applied on various members, and members are designed for those final loads we decide. Same way, electrical systems are accordingly decides, mechanical systems are accordingly decided. You cannot say if requirement is 10 kW, for example, 1000 kW, and you just give 500 kW, system shall not work. That's called calculation, and that's called coordination. You have to buy machines, you have to buy transformers, you have to buy switch gears, you have to buy so many other machines, or you can say HVAC equipment, air handling units, chiller unit, or package unit, or you have to buy split units or some other lifts. You have to buy all those items depending on prescription of specification, and depending on what you are going to do with that, what load distribution you are providing for that machine, and what is the requirement of that machine. This is all say a kind of compatibility. If suppose your machine is whatever load and your base backup of electrical doesn't suit it, it gives lesser one, your machine won't work, or the more one, still it's not right, because the requirement is rated one, otherwise it is waste. So that's what I'm trying to say means services are very important. Coordination is very important. Coordination between architectural and structural activities also is very important. You cannot simply can exclusively say, oh, this is architectural requirement I have fulfilled. Architectural requirement is to be fulfilled by structural arrangement, and structural arrangements are to be fulfilled by doing complete design, complete shop drawings, and we have to give room to services flow, services installable in that area, because services means length, width, and depth, and also other factors. Means we have to make sure that structure is not affected by services. There should be clear room for services in all areas wherever services play their role. This may run through walls, or this may run through slabs, or this may run through below floors. Wherever services may run through ceiling plan, whereas plan of ceiling exists, these may work wherever these are required to work. Not only service takes with it another service, you have to keep in mind no service is independent of other service. It has to be in tune with other service, and your structure should be in tune to all services. These are important arrangements, these are important design points, or in fact coordination point. We all stand together and we work together. That is meaning of coordination. We work together, we stand at one time, we talk to each other, what's problem coming in this and what's problem coming in that. And we have to find solution which should be commonly acceptable by all parties. All parties means stakeholders on site. Coordination is technical, coordination is design one, coordination is site one, and coordination means there may be changes in drawings. We have to keep a watch on that. So we have to be very careful with that. So coordination, you can say, is mother of job. Coordination with erection work, structural steel work, coordination with precast work, coordination cast in situ work, coordination architectural work. There is no one, no two. And these technical activities which we say, these are very important from point of view of you can say point of view of meetings. We conduct meetings for purpose of coordination. It's not that it's our interest to conduct meeting. Meeting means when you sit together with problems. Either you say there is no problem, there's one point. If everybody says no, there's no problem, everything is moving right. Okay, that's very good environment. That's very good, you can say, combination or collection of people and doing job. But it rarely happens. Meetings are conducted, materials are involved in that meeting, machines are involved in that meeting, problems are involved in that meeting, materials, which material we want to buy or we are going to buy, those processes are involved in those meetings. Issue of shop drawings and issue of working drawings are involved in those meetings. You can say many other factors involved in like what's happening on site, what service activities we are doing, how we are doing, where is the problem in one. So factors which are true. So factors which are true, I can't name them. So that's what I say. Meetings are conducted and we call them technical and coordination meetings. Generally, it is a sit for everybody, and generally in structures oriented projects where buildings are major components, it's building related contractors, engineer or site agent who is in charge of the project conduct such meetings. They conduct such meeting as chairman of that meeting, because this work is between this this responsibility lies between contractor and services subcontractors or services sections of that main contractor, I mean to say of contractor. So this meeting is actually first of all very lengthy in the sense that all technical talks in presence of some consultant possibly, and we have to see ourselves where we are wrong, we are right. With record that if there is a delay in material submissions, why is there delay? If there is a delay, some genuine reason is there that is justified that this material may not be available in the future, then there can arise a question, why not to change this material to which will be available in future? But it's ongoing project. You have to be very careful. Other party can play. So technical and coordination meeting, though it is conducted once or twice a week, maybe in a week or in 15 days, whenever it's thought that now it's requirement of meeting, so many issues are involved and we have to solve those issues. Well, I think that's right approach we have to understand. This is not mandatory that you conduct if it's not required. But for review purpose, it is done, because generally it is done in advance of main meeting, contract meeting we call that, or progress meeting we call that. A little before that, you can say 2 days, 3 days, 4 days, 5 days. Little before that, this meeting is conducted, and if nothing is, there's no existence of any problem, there is exists something, and that is progress. If there is no problem, progress can be evaluated, agreed upon, that we agreed this much, or this is pending, why it's pending. If there is a problem on material, that can also be discussed. Why we have to buy only this material and other cheaper materials are available? There can be many reasons for that. You have to understand those points. Meetings are very important that way. I'm not saying sit down without anything just to take a coffee or tea. No, it's not that. Because that time, you're talking to each other, it's being recorded. It's better than issuing 1 minute. So coordination is very important in work. And where there is a good coordination existence, there is no major problem. That point we have to understand well. Some people say coordination, all time talking of coordination. Yes, all time talking of coordination. Because coordination is a combination of group of engineering. Coordination engineering itself, which is a specialized field. Everybody cannot understand this until you have good experience on hands. Without experience, you can't do coordination, or even if you do coordination, you can't take results, you can't decide something. So that's a question mark. No issue. You have to do it. So let's go. A lot of talking is also not necessary. Coordination means it's not simply design coordination or drawing coordination or material coordination. It's also coordination on site, coordination on areas. When we say we are going to pour this slab, what is that? We are going to pour this slab. So what is required? Whether points very important or required. We have to pour slab means what we have to do. Is it gone? God, I lost it somewhere, I think. Hmm? No, no, it's not that. I think I got gone wrong. Slab is raw. I'm talking of slab because slab is a complicated item, what I understand. Complicate item in a sense that it takes time. First of all, it's not one day job. Sometimes it takes weeks. It depends on what type of slab it is, and sometimes it's done early. But there is coordination in this, big coordination. Maybe sometimes something is pending on site in design or in compatibility mode. We're not able to decide something. In that case, how can we do that service? Service is not done. If we do not do that service, then we start those services at required points. We can't pour because once it's poured, they can't take out. So until it is surface mounted or it is to go to wall or somewhere else, we can't take decision. And even also in case of wall, it has either to pass through one slab below or one slab above. So in every case, it is a complication. So when we do preparatory works for slab, that point must be very, very clear to everybody. Sometimes side decisions also required to be taken. That's called also side decision. You cannot say, okay, it means sometimes say, okay, we write in drawings also do this to requirement, to site requirement. It's written many times I've seen because coordination has not helped to solve this. So you have to depend on site work coordination. What work we have to do. It's not simply that we work to preparatory work and cast it. You have to work on activities. You have to provide inserts for every activity, and those may sometimes cause which cannot be seen, which could not be seen on drawings, which could not be anticipated on drawings. That could be caused on site. Sometimes many pipes cross each other, electrical conduits cross over each other, or there may be some other clash in other pipes, or in other openings there may be clash, box out openings, or you can say lockout openings, whatever you can say. You have to resolve those issues on site, and if you don't resolve those issues on site and continue as it is a question of problematic issue. Problems would emerge. We have to check that. It's not simply a statement I'm trying to give you. Means preparatory works are done once, not every time. Only one time you have to do preparatory work, and that work is enough for your costing. If preparatory work is successful, means you can pour concrete. If preparatory work is not successful, you cannot say that you can pour it. Even if one item is pending, you cannot pour it. And you cannot also say, I leave this item here and pour remaining. That's also not practically possible, and that's not permissible as well, because RCC material is different. You cannot change it once you concrete it. You cannot change it. You cannot take it out. So we have to be clear. We have to be explicit on this count. This is very important one. You can't change it. So work on site is very important, more important than drawing, because there will be clashes with shutters, there may be clashes with steel bars, there may be clashes among services, and our minds are different. Architect minds are different. Your minds are different. We have to make a policy that we will do zero approach. We go into world of coordination on site, and that's very important. So I said that slope suspended slab is actually target object, which is ultimately cover up for all structures. There are no one slab, there are many slabs in every structure. These slabs are different kind of means. These provide you protection, these provide you with roof or floor above, and this slab is having so many inserts within its volume. So what we should think about that? It's a big point. Means, can we take slab just a element or component, or we have to think of this that it is going to serve in future, and if it serves in future, all columns will serve, all beams will serve, and if it doesn't serve, means all other supporting elements are useless. This point we have to understand very clearly, very clearly. What's our role here? When I say role, means role with everyone, role with nature, role with some health issue like COVID-19, role with, you can say, use of building, and quality, role of that quality. We try to infill input in this system. All this would require considerations. I'm not saying just make a drawing and repeat as you repeat it all the time. You can't do that. Means your money, your material, you can import from anywhere. This is available, I import from here. Well, I think there's nothing wrong in that. After all, to buy, you do, but slab should be competent. Slab that you pour should be consistent. You should have good profile, good levels, good orientation, good quality concrete on this, without causing, you can say, flash settings, without causing cold joints. All those which we generally consider, have to do that. So we have to depend on temporary works, preparatory works, concrete pour works. These are important works. Slabs do look very easy, and people don't take it seriously. Particularly here, I am, people do not think seriousness should be given to people. Well, I consider slab is very important material, very important material. I should say, it's after all a component of building. It's very important one. We cannot we cannot run away from it. We have to explain everything. We have to understand everything. I've seen quality of slabs in many sites, and really I'm disappointed with that. Disappointed. Even level controls or alignment controls, forget that. Don't worry about that. Don't worry about anything. When you don't worry about anything, I say, I know all. It's, you know nothing, in fact. I make two statements. I know all. Okay. Now, temporary work is very important for every slab. Means you have to access to level where you have to work, and that access is given only by access stairs, because ladders cannot be used for such purpose except for limited environment where it's safe. So you can say check that preparatory works have been inspected in all respects. Inspection is very important. Inspection of all activities one time. Once you do preparatory works for slab, after going through all drawings, of course it will take some time. You have to supervise well, because you cannot trust all carpenters, you cannot trust their people, because boring job, they say, they talk themselves, they stop them, they don't stop. So we say that once slab supporting system is over, and you have taken third party representation for approval, your work to that extent is over. But safety, whose lives, who is responsible for that? Point is that even if you have taken third party certificate, ultimately responsibility lies on your heads, because you are a contractor or you are an engineer. Both are responsible for that. And if I am responsible for that, I am supposed to care for that. That's also an important point. We have to care for that. That care is very, you can say, you can't say that it's easy. Okay, it's normal slab. There may be industrial slabs also. There may be other slabs also. Very thick slabs as well, where warehouses of industrial buildings or such where extensive loads come, and say, oh, it means you have to think yourself how to handle coordination before concreting. It's very important part because it's your responsibility to do correct job before concrete. If there is an error, it can be corrected, and people do that. Means error may be in alignment of sides, error may be in levels, or error may be in reinforcement somewhere, or some rust you have to remove. Right? Don't be hurry. My dear, be very systematic in this case. Being very, you can say, clear about what you have to do. First requirement is safety. During pour, you must be directly responsible for safety and whatever you have. Then we say, I have checked everything. I have checked thickness, I have checked lines, I have checked levels, I have checked supports down in addition to what that vendor supplied it. And I have already changed for sewage cleaning, and I show that during slab itself. So quality of concrete is very important point in suspended slabs. You cannot compromise. You must make a plan for that. I think that is only way for best performance. Don't know, don't think, don't think that you know everything. Every every work is new for us. When work is new, then we must plan properly. So it says make sure that core plan has been finalized within method statement and plan details provided to concrete supplier. Supplier must know what is your quantity approximately and what is trial mix design that you approved for this. That must be given clear advice and instruction when it comes to site. I don't know what first I just want to read. When you start concrete pour, means you have clearance from approval authority and you have given clearance to your machine plant You want to start immediately or you want to wait for good weather condition? That your consultant has to decide. You have to decide. Once decision is done, then concrete can start without causing any problem. So you have to start slab pouring, which is very difficult exercise, very careful exercise, you have to take care, every case. All controls must be sure, all service must be there, all plants must be there. Big pour it is, not small pour. I'm talking big pour. Maybe you have to use 2 or 3 pumps, it depends. Not necessarily you have to use one pump, we have fixed order. We want access to people we need. 2 groups, 3 groups, depending on number of pours. You may require masons, you may require carpenters, you may require helpers, you may require, what do you call, all PPs for them. You may require access fine to that route, access to that slab. You have to require water there. You have to require all levels, all profiles, all electrical persons, or those who are mechanical others for some adjustments on site. And you have to define time limit in which time you have to finish this. You have to ensure temperature of atmosphere, temperature of concrete, qualities, all that. It looks that there are so many points you have to consider, and not only consider, you have to make sure that these points are done when your concrete arrives. You have no right to keep it standing. Why you allow this letter? No, you can't allow that. You have to use it because it's question of time and cost. Slab concrete is not slim pour, it's not thin pour, it's a kind of you can say fast pour. Yeah, I may not say heavy pour, but it's fast pour. Your transit mixer of 8 cubic meter can be emptied in 5 minutes even if you are good in preparedness, if you are having no tension of some incomplete work. Then it's up to you from which end you start according to your plan. Even if you use 2 pumps, 2 mixers can arrive same time. It will take about 5 to 10 minutes to take tests on site, slump test and temperature and air voids. In first go it will take some time, but when you keep it up, already mixers are there who are delivering or placing, disposing their material onto site by following up. Mixers go to their testing. So it happens like that, it moves like that, there is no other way out. And once you start, peacefully, with patience but with speed. Don't be nervous. Don't forget, in nervous you make mistakes. In nervous state you make mistakes. You must have good supervisor, or you can say concrete supervisor. You must have good site engineer, and they can start from one end. Starting is always a problem because starting means causing some possible defects. No shooting start, but that's what I say. Start without panic. First release of concrete from batching plant is very segregative. Keep in mind, always it is some meanings because of pumping start, because of pumping system. Small quantity of concrete is always a problem. A small quantity, I mean, it is not in cubic meters. Say 1 bucket concrete, small bucket, that always segregates due to initial start of pump. Either take that concrete into some bucket or somewhere, or directly dispose that outside somewhere. But if you collect that somewhere in some bucket or something, you will know what concrete is that is. But after that, it will start coming in proper mixed form, and that concrete you start laying into your first place. Do not pour directly into beams. There is a reason for that. It's not that it's wrong, it's not wrong. Because pressure of concrete pump is very high, and high not in sense of static fluid flow, it's high in terms of impact, in terms of vibration. It comes out as a great vibration, and that vibration can impact on sides or beams, which is a risky one. So what practice says that trend practice says that because you have to start with beams, if you can start with the slabs where there is no beam, that's different issue, but generally beams do exist. Download beams, downstand beams exist everywhere. So just do not rush into slab or into beam directly. Really receive your concrete from pump boom at edge of beam or slab, means there is an edge where beam sides, internal and slab deck meet together. Try to place concrete there in longitudinal run parallel to beam. Don't even put on slab immediately. You may say some area, say 40, 50, 30 centimeter on slab, and when you drop from pump from that edge, half of or more than this would go into beam. Very small will lie on slab, which do not harm it. And also do not take full beam. If it is small beam, section is low, is different, but if it's little more, you have no right to take concrete into more than 40, 400 mm depth, layer depth, which is set criteria. I mean to say, set criteria in sense of the vibration, in sense of application of vibrator, compaction, as a compaction of concrete. You take around beam all over and fill around 400 mm. Let arbitrator operator follow you on a vibration. This pipe, this boom shall be held by two or three persons so that it should not go out of control, and you take around up to some predetermined location. I will come up to here and go back. When you come up to here, okay, you have laid this, go back to initial place and start there. Go in such a way that you have a chance to, in second case you have a chance to fill beam to level as well as slab also in some areas. So you have covered many beams, start filling beams again from point to point, and do not rush out, but also take some portion of slabs in that vicinity, and that can be done full, I mean to say full height, so that there is a chance of masons to start leveling by their float, because already you have applied vibrator in beam, and if slab is more than 20 mm, 15 mm, I'm so sorry, 150 mm, means you have to apply vibrator there as well at different places. Maybe in thin slabs your temper would do, but otherwise vibrator is a must. If you don't apply this big vibrator, you can apply smaller vibrator, but you have to apply. And you once you apply vibrator, then you are leaving free scope of work for masons who are following your finishing of that item, wooden float. And you can say you go on moving, and also other pump which is working, that's also working similarly. that crew is working there and this crew is working there. So you follow in a sequence, don't say that's far away from here. No, just keep in adjacent area so that your poured concrete and that gang's poured concrete both meet at one point. So it's good one. When you do like this, you can go further in that calculated range and also in your range, and you can say you can go through around slab, then you can start coming back to previous position and filling off slab up to profile level compaction, and then let members of gang masons work on that. This is generally circulate, this called site work movement on concrete, because concrete is useful only if it is compacted in hot state. Hot doesn't mean boiled, but hot means, if you call green, you may call it, if not hot, in green state. And that's what we say. We don't allow the concrete set prior to other layer is put on that. Once layers are over, level comes in, then it may set, doesn't matter, because if it sets, both layers would set, not one layer. And that's therefore called hot joint. Means both concrete were hot chemically, and these are not shrunk. Now they have taken position is concrete material, and therefore we can say work is professional. So what says, pour plan must give complete details of pour, including quantity, time of pour start, frequency of each truck release from plant, slump temperature, hours of pour, number of pumps, range of pump to cover whole pour, design mix reference if specifically applicable, circulation route on site for entries of equipment and exit, site testing from laboratory of batching plant, police permission if required. Make sure that type of pumping equipment required is well known to RMC, plant manager or organizer. While it's suggested that RMC plant manager better inspect site for assessment of specific pumping equipment requirements. So this was just passed on now. We have already laid concrete. So what we do is, in this there are so many restrictions are given that pumping equipment which one is required, then you can say let plant decide to satisfy your need. Then supervising personnel or personnel should be available when concrete is delivered. Those supervising personnel quality and yours, construction person. And we have to make sure that concrete crew gang required is the strength for concrete is available on site. Timings we have to decide, temperature we have to decide. It's already prescribed, but we have to make sure that acceptable temperature range exists. Concrete timing should match those hours, and then temperature of weather as well as of concrete shall be within limits. RMC should supply concrete having defined temperature, even if ice addition may be required. Concrete should be supplied with agreed frequency of transit mixers arrival. A place should be selected for washing trucks after emptying so that laws are visible. Loss permitted means all equipment and tools to be used for concreting must be checked for their operations. Dedicated vibrators and standby vibrators must be checked to be in working order. All curing arrangements should be made available on site to initiate timely curing. For major slabs, construction joints must be prepared in advance, and also stop ends for whatever emergency should be prepared to avoid 11th hour testing duration. So what I should say that for major slabs, construction joints must be prepared in advance and also stoppings for that prepared for meeting any emergency. And carpenter and steel fix are required everywhere below slabs to monitor, meet certain emergency requirements, say some support slackens or some settlement occurs somewhere, just to control that. Now what to do? If there is some problem we see, immediately we have to correct that. Electrical conduits may be problem. Some socket switches, maybe it's not switches, socket I can say, but it's not, it's called SP switch panel arrangement. Two walls from this was right. So to be very honest, professional should be very honest and committed. If a professional is not honest, is not committed, I can't say that's work. We cannot depend on those professionals who are not committed, who are not determined. They just want to do formality. But concrete does not depend on formality. Concrete depends on right placement, professional placement. You have to organize in a way it should be done. Proper planning, proper core location, proper application of vibrator, and proper curing are main points that we have to keep in mind. Otherwise, this is just the material, this is not professional work. Positioning of concrete pump location and truck's location should be clear. And then we can say electrical supply chain. Adequate electrical supply arrangements must be kept on site for whatever activity we're doing. That is all time done. Adverse weather conditions may demand something else. You may demand, okay, it's very humid, can't do concrete. Let me say something. But concrete pouring is very fast activity for slabs, and this should not be missed. As fast as it can be done, that is better. Then you can say all facilities you have to provide to your crew, your workers, water, and if required food, hot tea, beverages, whatever. because it's hard work and they pull concrete by their equipment, hand equipment tool, which which makes it impossible to use interference. Well, when say drinking water or cold liquids for consumption must be made available on location of concrete. Location of concrete you can to drink to avoid both dehydration and sunstroke. And I already said food time and drink time and all that. For workers' passive movements, replacements should be made available. Then you can say I already explained about beam and all the, how you have to pour. Says concrete beams beams have to be poured first, but not full height, full depth. Concrete should not be poured into beams directly, but received on slab edges to avoid impact on beams sides forms, so as to avoid opening of or dislocation of forms. Concreting should start from one end and progress gradually, completing first stage beam pours, second stage of pour rotation should give concrete its level in right profile, including slab portion. If more than two or three pumps are being used, pour concrete. So I think there's an error in spelling. Pour concrete on. It's not this what I've written. It's some error. I'll correct this. Concrete on designated areas per plan, and related areas must be given individual attention so that all pouring areas meet at one point as soon as possible prior to formation of cold joints. Handling unexpected construction joint in case due to certain emergency construction joint is required, kept at certain on-site agreed location, on-site formed stepped section. Formwork at convenient location where concrete has not reached, and then complete pour up to that location, vibrate and then comply with necessary procedure to finish concrete for curing. Concrete pour cannot be commenced with at that joint for remaining portion without complying with old and new concrete specification criteria. Construction joint formwork shall be removed not before 48 hours, cleaned and scabbled, remove all latents so as to expose all aggregate, all concrete debris, dust and dirt shall be cleaned. All reinforcing bars Can say core activity, can say all concrete debris, dust and dirt shall be cleaned. All reinforcing bars, splashes by cement slurry shall be brushed to expose the steel surface. Approval of pouring to be requested after after it is received, new pour shall commence to complete all leftover areas. Pour activity explanation continues. Now, if temperature is high, immediate protection of surface has to be applied. In case of 2 pumps or 3 pumps are installed, concrete can be started from as many locations as available number of pumps, but no cold joints can be allowed. Concrete pour plan should provide as all details. Concrete pour plan should provide all details, and site supervisor must be handed and explained plan in details so that reliable communication is made to all present on pour location. Carpenters available must keep a watch from below slab forms that no support should yield or concrete come out from forms, or if there is cause some other unknown problem to handle that contingent situation. Similarly, steel fixers have to check steel fixtures have to check that no bars are dislocated, and if so, immediate reinstatement of bar should be carried out. Concrete pour plan should provide all details, and site supervisor must be handled, explain plan in details so that reliable communication is made to all present on pour location. Carpenters available must keep a watch from below slab forms that no support should yield or concrete come out from forms, or if there is cause some other unknown problem to handle that contingent situation. Similarly, steel fixers have to check that no bars are dislocated, and if so, immediate restatement of bar should be carried out. In case of application is required for waste areas, you can say what you say is carpenters available must keep watch, from below slab, as I said, and whatever is happens, they have to handle that contingent situation. And same thing, steel fixers have to do. If there is a dislocation in bars, it should be corrected. Steel fixers have to check that no bars are dislocated, and if it happens, immediate reinstatement of bars should be carried out. In case of application is required by power float, it is to be made sure that concrete is hard enough before applying power float. In case immediate cracks are seen, must be filled with cement and sand in form of grouting on wet concrete. Post finishing cover surface. Post finishing cover surface with polythene, cover surface with polythene sheet or spray curing compound immediately. Check that last truck does not reach immediately. So I say make sure that check that last truck does not reach immediately after blast 4, but one reaches, but wait until all previous concrete is consumed. Make sure that the whole truck quantity shall be consumed, and if no, then order requirement only. For last dispatch, procedural routine curing shall follow. Later on is defined within method statement. All rubbish should be removed from location and all concrete spill over upon reinforcing bar is still all items say all rubbish should be removed from location and all concrete spillover upper reinforcing bars and columns should be cleaned. Concrete shall be level to fixed top profile and ensure that level of poured concrete is achieved and doesn't go above fixed lines, which may require additional grinding. Do not allow any worker or person to walk on finished surface until concrete sets properly. Keep all exposed projecting bars well protected in wet humid conditions so that surface of these bars are not rusted. You can say keep all exposed projecting bars well protected in wet humid conditions so that surfaces of these bars are not rusted. Rusting is a significant issue and therefore it is of utmost importance to give good care to protection of all site installed or placed bars. Continue curing for agreed procedure by laying on exposed or unformed surfaces saturated Haitian cloth covered by polythene sheet and all time water must be available to keep required temperature, which must be observed in, can say, continue curing pregnant procedures by laying on exposed unformed surfaces saturated adhesion cloth covered with polythene sheet, covered by polythene sheets. And, well, you can say that also keep formed surfaces at low temperature by spraying fog water instantly. There is a specification of concrete which you have to read. I will read later on for complete information on that. And these are basic precautions also if there are some upstands on somewhere slab, not downstand, upstand for purpose of some other. So you have to pass those, wait for those surplus. Yes. We have to understand so much in this, not just by virtues of our clear. There may be some upstands in some cases, not necessary. There may be in cases and that upstand formwork, it's not very big upstand. We can also place formwork of upstand and we can cast it simultaneously with other beam areas and slab areas because monolithic casting is always better and it will have a very small quantity and you always think of that this quantity is coming in. I'll buy a full. I do full in that case. So checklist. Now concrete of slab is very important item for residential buildings, for other buildings, and applies to industrial buildings as well, commercial buildings as well. If we can we have to be very careful about this. Now I think it's already 13. What we have here is this, we have to go to we just get off this. we have to consider these points in this. Various methods are still there, check methods are still there. I'm going to add more and more on those. Meanwhile, we have to consider slab more very important, because slab is ultimate requirement, and if there is some misalignment or mislevel in slab, it's very difficult to correct it. You can't correct that. Means it's very important that you have to be careful, very much careful about slab core, and there is no way out. That let's sort this out.